Hi, and welcome to my talk, Streaming Your Database, Easier Said Than Done. Thank you for your time. So let me introduce myself. My name is Sigal Shaharabani. I am a technical leader and a group leader in Tikal. We are an Israeli software company. We provide hands-on senior and expert developers to companies in the high-tech industry across Israel and worldwide. As to myself, I am almost 30 years professional, and I'm an Israeli folk dancing enthusiast. So let me start our journey. It started in February 2020. I was invited to the officers of a big cyber company in Israel, and they asked me to build them a CDC. This started the journey. So let us remind ourselves what CDC is. It is the acronym of Change Data Capture. It means the process of identifying and capturing changes made to data in databases and then delivering those changes in real time to a downstream process or system. What it means is a software system that tracks the data changes and acts upon them. So let us put this in context of the big cyber company. What they had is what we see in this diagram. On the left, we had customer systems. They had a lot of customer deployments in the field. It was on-prem or in the cloud. Every customer deployment has its own database. It was a Postgres instance. And what they wanted to do is synchronize some of the data that was in these databases to a central data lake and develop software upon this data to analyze this data. The kinds of systems that you can imagine is, of course, research and analysis for research purposes, back office applications, and mostly multi-tenant applications that they would run in the cloud instead of on the software systems. So I said, no problem. We are very fortunate to be in a world that has off-the-shelf CDC tools like the Basium and, of course, Airbyte that is our sponsor. So why not use them? And that's what I asked them. And they said, well, we tried it. It's not 100% what we need. We have to build it ourselves. And this led us to what I used to call mini Debasium, or perhaps it was a double Debasium, and we did it ourselves. So let's first see why the Debasium doesn't fit us. Why do we need something else? So this is a diagram of the Debasium architecture from its website. What it shows is on the left, we have source databases. We have Kafka clusters. What the Debasium does is write connectors that know how to read the data changes from the databases. In this case, there's MySQL and Postgres, but there are many popular databases. So they provide the connectors and they push the changes into Kafka topics. And if you are a consumer of this data, all you need to do is specify the targets for this data, meaning the Debasium will pour the data from the topics to your destinations. In this instance, we have Elasticsearch, but we can have a relational databases, files, another Kafka, whatever you need. And this is very flexible and it has a many-to-many relationship. So what's wrong with it? Why doesn't it fit? So what happened is that they wanted to enrich the data, meaning if you are in the target software, when you want to present it, most likely you will want to join some data from multiple tables. And they said, why should we join multiple times? Why don't we join the data once before we send it to the cloud? And then we will not need to join it multiple times. So this is what they wanted to do just before sending the data to Kafka. And of course, the Debasium doesn't allow this. And we checked. This led us to building a solution of our own. So before I progress, I want to say something as a disclaimer. Even in hindsight of more than 3 years after this project, I am still against it. I discourage you from going this way, and I will tell you why. The issue is that this is a data that tracks changes. So when you present the data that was joined many steps earlier, this data that you present may have already changed. So this is not a good track to go, and I discourage you from that. And unfortunately, in this project, I was not able to do that. But I think in hindsight, they agreed with me. So remember that. But it doesn't change the rest of our talk. So let's see what we came up with. So we had on the left again the customer databases. They were still Postgres. we have the purple rectangle. This is the service that I wrote in Golang that read the changes from the databases, just like the Bayesian connectors do. It wasn't very difficult to do. There are libraries that do that. And then we pushed it to a Kafka that belonged to the customer, only the customer data. So now we have the black rectangles. That's the enrichment process that was written in Python because we had some legacy code that we could use. And that enriched the data and pushed it to a central Kafka that was in the cloud where the data should be for the applications to use it. So now, when the data is in the cloud, all you need to do if you want to use it, just consume it from Kafka and do whatever you want with that. And as you can see, I put the Kubernetes logo because we use Kubernetes for the running of and deployment of these applications. So now you may ask me, did you really have a Kafka cluster for every customer? That sounds very expensive. And that is correct. We didn't do that, in fact. That was the initial plan, but we made a better plan. What we did is first, we didn't deploy the Kafka clusters on the customer's resources. We deployed them on our resources, meaning in our AWS account. So that didn't change the bill for the customer. And also, we grouped multiple customers on the same Kafka cluster, so we will have less Kafka clusters. So of course, that requires security, so you have to be very careful and make sure that the data doesn't mix. So it seems like we're all done, right? So not really. You have to remember that once you start running data in a data system, stuff starts to crash and you start getting complaints that data is not coming, your services are crashing, and you get all kinds of alerts, so that's not good. So in the rest of my talk, I will show some tips that can help you when you plan and develop and test your system. So first thing is the replication format. Meaning, when the database externalizes the changes, what it does, it usually writes the changes into some kind of a file, and the Bayesian or any other connector, it reads these files. And it has many formats that you can use to write these files and read them. So I encourage you to explore this topic, and I mostly encourage you to use binary formats and not plain text formats. This will affect your performance tremendously. Use it and don't be shy. Second issue that you have to remember that this is a system that transfers data all the time. Whenever something changes, data starts moving along the pipelines. So you have to be resilient, meaning you can't crash, and even worse, you cannot freeze because you have to be sure that your system is still transferring data. You cannot handle every crash. So you have to plan your system and your code to be very resilient, to catch every error and log everything so you'll be able to handle them later. Next is the load. You have a lot of data that you're transferring, but you don't necessarily need it. So be prepared to reduce it by doing a lot of filtering out. Like what we did, we used our internal logic to throw out a lot of data that we didn't need. And also we did some deduping with LRU caches. And because we needed enrichment, we also did that in batches. And that also reminds me that you have to use benchmarks for all of this to test your system. So how would you do that? You would do that with monitoring. What we did is we added a lot of metrics in Datadog, and we presented all this data in a dashboard that we designed. And this allowed us to track every service on the customer side or in the central cloud system. So whenever we had a problem, we could filter it because we tagged all these metrics with the AWS region, the customer ID, and the database table. So we knew at every point what's breaking our system, and I encourage you to do that. So to summarize, what you need to do is remember that this is a data system, and to have it work, you need to understand how the data looks like and how it will affect your performance. Second, you don't have the privilege to change it, so make sure you just build for resilience, and don't forget to monitor. So if you are interested in this, please read my blog post in Medium. My handle is Sigal S. I have a lot of posts on this topic. You are more than welcome to find me on social media. I am available at Twitter, X, Medium, or LinkedIn. My name is Sigal Shaharabani, and the biggest obstacle is to spell my last name, so I encourage you to copy my name for the slideshow or from the website. Thank you for your time.